Welcome to Geometrix Galaxy. Good morning students. Today we will see chapter 1 number system, operations on real numbers. First we will see the basic rules, then we will do the example problems 11, 12, 13 and 14. Before we start with solving problems on operations on real numbers, we need to understand certain rules. Okay, let us see what are the rules. If we take a rational number and an irrational number and we do the operations addition and subtraction, we will get the result as an irrational numbers. Okay, let us see with some examples. I have taken 5 a rational number and an irrational number 3 root 2. If I add both, I get the same 5 plus 3 root 2. Okay, 5 plus 3 root 2 is an irrational number. Again, I take the same rational and irrational numbers and do the operation subtraction. So 5 minus 3 root 2 is an irrational number. So in the two cases, we get the answer as irrational numbers. So students, you need to keep in mind, when we add or subtract a rational number with an irrational number, our answer is irrational number. Now let us see what happens when we do multiplication or division operations with a rational number and an irrational number. The result is an irrational number. Here we will see what happens when we choose the operation multiplication and division. So when we do the operation multiplication and division between a rational number and an irrational number, the result is an irrational number. Now we will try to check with certain examples. I have taken 5 a rational number and an irrational number 3 root 2. I am trying to multiply this. So 5 3s are 15. 15 root 2 is the answer. So rational number 5 and an irrational number 3 root 2, if I multiply, I get 15 root 2. That is an irrational number. Now let us see what happens when we do division operation. So 5 a rational number divided by 3 root 2 an irrational number, which gives the result as 5 by 3 root 2, which is also an irrational number. So we need to understand that if we multiply or divide a rational number with an irrational number, we will get an irrational number. Now let us see what is our next rule. So the rule says, when we take two irrational numbers and do all the 4 operations, addition, subtraction, multiplication and division, we will get either a rational number or an irrational number. Now let us check the above rule with few examples. We will do one by one all the 4 operations. First we will do for addition. So I am going to take 2 irrational numbers and add. Okay, so I am taking 2 root 2 plus 3 root 2. If I add, I will get 5 root 2. That is, irrational number plus irrational number gives an irrational number. Now I am going to do the same operation addition with the 2 irrational numbers 3 root 2 and minus 3 root 2. Okay, we will see what is the answer. If I add 3 root 2 with minus 3 root 2, the answer is 0. 0 is a rational number. So with the 2 examples, we come to the conclusion that if we add 2 irrational numbers, the answer may be a rational number or an irrational number. Let us extend the example for subtraction. Now I take 2 root 2 and 3 root 2. If I subtract 2 root 2 minus 3 root 2 is equal to minus root 2. So irrational number minus irrational number gives an irrational number. We will take another example. 3 root 2 minus 3 root 2. That is equal to 0. So we get irrational number minus irrational number is a rational number. So our conclusion is, if we subtract 2 irrational numbers, we may either get a rational number or an irrational number. Now we will check for multiplication and division. 2 root 2 into 3 root 2 is equal to 12. That is 2 3s are 6. Root 2 into root 2 is 2. 6 into 2, 12. Here irrational number into irrational number gives you a rational number. Next we will take 3 root 2 multiplied by 3 root 3. Now 3 3s are 9. Root 2 into root 3 is 6. So our answer is 9 root 6. 9 root 6 is an irrational number. So if we multiply two irrational numbers, the product may either rational or irrational. We are going to check for division using two irrational numbers. 2 root 3 divided by 3 root 2 is equal to 2 root 3 by 3 root 2, which is an irrational number. But if I take 3 root 2 divided by 3 root, the quotient is 1. Here I am taking two irrational numbers, but if I divide, I get a rational number. So our conclusion is, if I take two irrational numbers and do division, I may get the quotient as rational or irrational. Now let us start with example problems of your textbook. Example 11. Check whether 7 root 5, 7 by root 5, root 2 plus 21, pi minus 2 are irrational numbers or not. Let us check one by one. 7 root 5 is nothing but 7 into root 5. 7 is a rational number. Root 5 is an irrational number. Just now we studied in rules that rational into irrational is an irrational number. So 7 a rational number and into root 5 an irrational number will give you 7 root 5 an irrational number. Next 7 by root 5, that is 7 divided by root 5. Again 7 is a rational number. Root 5 is an irrational number. We know that rational divided by irrational is irrational. Therefore 7 divided by root 5 is an irrational number. Next root 2 plus 21. Root 2 is an irrational number, is a rational number. We know that irrational plus rational is irrational. Therefore root 2 plus 21 is an irrational number. Pi minus 2. Pi is an irrational number. 2 is a rational number. We know that irrational minus rational is irrational. Therefore pi minus 2 is an irrational number. This is example 12. Add 2 root 2 plus 5 root 3 and root 2 minus 3 root 3. So if we add, so in addition we can combine only the like terms. Here we can combine only the like irrational numbers. 2 root 2 can be combined only with root 2 and 5 root 3 can be combined only with minus 3 root 3. Therefore 2 root 2 plus root 2 is 3 root 2. 5 root 3 minus 3 root 3 is plus 2 root 3. So our final answer is 3 root 2 plus 2 root 3. Now example 13. Multiply 6 root 5 by 2 root 5. 6 root 5 into 2 root 5. First we will multiply 6 and 2 followed by root 5 into root 5. 6 into 2 is 12. Root 5 into root 5 is 5. So 12 into 5 is equal to 60. Example 14. Divide 8 root 15 by 2 root 3. Now let us check, students, how we can simplify this question. So in the numerator we have 8 root 15. This 15 can be expanded as 5 into 3. So I write it as 8 into root of 5 into 3 divided by 2 root 3. Again root 5 into 3 can be written as root 5 into root 3. So I will write the numerator as 8 root 5 into root 3 divided by 2 root 3. So we can cancel this root 3 in the numerator and denominator. So our answer is 8 root 5 by 2. Further, I can cancel 2 and 8. So I will get in the numerator 4. So my final answer is 4 root 5. That's all in today's video, students. In the next video, we will continue with the example problems 15, 16, 17, 18. Thank you for watching my video. If you find Geometrix Galaxy helpful, consider subscribing to my channel. And please don't hesitate to recommend this channel to your friends. Thanks for watching.